Hello and welcome back. I've got another short video for you today. Yesterday we were talking about angles formed by chords, secants, and tangents, and today we're going to talk about segments that are formed by chords, secants, and tangents. So just a few more new formulas for us to know. I put all the formulas on your formula sheet, which you can use during the test or the practice test that we're going to do. We don't expect you to memorize all the formulas, just know how to apply them. So we're actually almost done with this unit, which is pretty exciting. Just a few more things. Monday when we come back, we'll do midpoint and distance formula again, just as a review. We did that at the beginning of the years already. And then we'll talk about the equations of a circle, which is probably the hardest topic in this whole unit, and we'll spend 2 days on that. Then we'll go ahead and move on to the surface area unit, which is coming up next. So moving right along. All right, segment links are formed from two chords. So here we have two chords. I broke them down here with separate parts. This is part A of it, and this is E, and then we have B and then D. So I broke those down just for what we're going to do in a second. So this angle here, special about these two chords, is that they end on a diameter, meaning this angle has to be 180 degrees. Well, if we look closely at this, if we connect these two lines here, so point B and point A, and then we connect D and E here, what do we know about the angle B and the angle E? If our central angle is 180 degrees, what kind of an angle is this angle? All right, so it is an inscribed angle, and we know inscribed angles are half of the central angle. So it's going to be half of the measurement of this arc. And if that's 180 degrees, this is going to have to be 9 degrees, right? That's Thales' theorem. We know all right angles exist somewhere on here. Remember, I've shown that, and I showed you on GeoGebra. So if we put another vertice here, anywhere on this semicircle, we know we're going to have another right triangle, right? So if I move this out of the way, we know this is also a right triangle. Okay, now right off the bat, if you just look at this triangle that we formed between two sides of the intersecting chords and the triangle here, what would you kind of conjecture about those two triangles? Anything special about them? Well, we already pointed out they're both right triangles, right? What else? Okay, well, you might notice something about the angles in the middle, right? So what's special about those angles? So this angle here and this angle here are vertical angles, right? So they have to be congruent to each other. All right, so if those two angles are congruent and these two angles are congruent, then what do we know about the two triangles? So we know the third angles theorem tells us this angle also has to be congruent to that one, which is actually because the arc BE is the same arc BE for both of them, and that's an inscribed angle of arc BE, right? And this is an inscribed angle of arc BE as well, so by the reflexive property. But so lots of different ways we can prove this with intersecting chords, but basically if the angles are congruent, that means the triangles are congruent or similar by angle-angle similarity postulate, right? Which is the most basic of all of our similarity postulates. Okay, so they are similar by angle-angle, which means so triangle ABC is similar to triangle DEC. So they are similar. We can write a similarity statement. That's again by angle-angle similarity. So if the angles are congruent, that means that the triangles are similar, so the sides are proportional, which means we can set up a ratio or a proportion for the corresponding side. So the side A is the smallest side. That's going to be corresponding with D, and then the hypotenuse along the side B is going to correspond with the hypotenuse E. So if we set up that proportion, it might look like this. So I'm saying A goes to D just as B goes to E. So there's our proportion. And then whenever we solve our proportion, remember we cross multiply. So I'm going to do A times E is equal to B times D. Now, when I do that, that's actually where our first formula comes from. The segments intersecting, the links of segments from two intersecting chords is going to be A times E is equal to B times D. Now, we actually don't have to do all this work to set up proportions. We just need to remember we do A times E. So we're multiplying the parts on the same chord. So this part times the rest of the chord is equal to this part times the rest of the chord. And that's our formula for the segment links of two chords. So you just multiply the parts on the same one. So let's do an example. So on this one, we have our two chords intersecting. So I'm going to do, well, let's see how it starts out. Okay, so 2 times x is going to be equal to 3 times 6. 3 times 6. Okay. And the order we write these doesn't matter because of the associative property of multiplication. We could have done x times 2 and then 6 times 3, or 3 times 6 and x times 2. So unlike setting up proportions, the order does not matter whenever we're multiplying, as long as we multiply the parts that are on the same chord. So the blue part with the blue part, the red part with the red part, just like we did here. All right, so we can simplify this. 2 times x is 2x is equal to 3 times 6, which is 18. Then we divide both sides by 2, and we're left with x is equal to 9. So this length here would have to be 9. If we look at all the other lengths, it kind of makes sense. It's longer than the 6, right? So yeah, it is 9. But it's not always drawn the scale, so be careful. All right, now what happens when we have two secants? So these are both secants because they intersect the circle twice. They go into the circle, then they exit. It's not a tangent. So the formula for this one is we multiply the outside times the length of the whole thing. So we got to add those together. So we'll start out with the outside, which is 3, times the whole thing. So what's 3 plus 5? It's going to be 8, right? So 3 times 3 plus 5. And that's going to be equal to the same thing down here. 4, the outside, times the whole thing, which is 4 plus x. So that's equal to 4 times 4 plus x. All right, now all we have to do is add those together, which is 8. So 3 times 8 is going to give us 24 is equal to. And then on this one, we're going to be distributing through, right? So 4 times 4 is 16. Then 4 times x is going to be 4x. So we have 16 plus 4x. Okay. So next step would be to subtract 16 from both sides. That's going to leave us with 8 is equal to 4x. Then we divide by 4 from both sides, and we get x is equal to 2. So simple formula here, we do the outside times the length of the whole thing when we add it together is equal to the outside times the length of the whole thing when we add it together. All right, so the only other formula we have is with a secant and a tangent. Now it's actually the same formula, except when we do the whole thing for the for x, that is the whole thing. The outside is the whole thing, right? So let's set it up just like we did the one before. So the outside, which is 4, times the whole thing, which is going to be 4 plus 12, okay, is equal to the outside, which is x, times the whole thing, which is x, right? So notice here we didn't have any part on the inside, any blue part that we had to add to it. So it's really the same formula. The formula sheet will break it out as a separate formula, but if you think about it as outside times the whole thing is equal to outside times the whole thing, that won't mess you up whenever you have tangents. It's also true if you have two tangents, but when you have two tangents, they're just going to be congruent to each other. All right, let's see. So we want to distribute through, right? So 4 times, oh, we actually don't have to distribute because we can add those together. So 4 times 16, and if you don't know that off the top of your head, just pull out your calculator. So let me clear all this out. So 4 times 16, okay, that's going to be 64. Okay, so 64 is equal to x times x. Now, what is x times x? How can I simplify that expression? Is it 2x? Nope, because it's not x plus x. Then it would be 2x. So if we're multiplying, what is repeated multiplication? Exponents. Good. So what is x times x? Should be x squared, right? So we have 2 of them would be x squared. All right, there we go. All right, so we have 64 is equal to x squared. So how do we undo a square? What do we do to undo a square? That's right, we take the square root of both sides, right? Do it to one side, you gotta do it to the other side. So what's the square root of 64? It's a perfect square, so it's just gonna be 8. Okay, there we go. So this length here would have to be 8. So 4 and 12, and then this one would be 8. All right, so that's it. That was 9 minutes. That's amazing. So we got through all that, just those 3 more formulas, really just 2 of them, because the tangents is repeated. So if you want to get out your assignment, we'll go ahead and go through a few of these together. Should be really simple. All right, so this one we have 2 chords that are intersecting. So we're going to multiply the parts that are on the same thing. Remember, if we drew lines connecting those 2, they're actually going to be similar to each other by angle similarity. So we could set proportions. So x goes to 5 just as 10 goes to 6 or whatever. But for us, we're just going to not cross multiply. We're just going to multiply the parts that are on the same chord. So we'll do x times 10 is equal to 5 times 6. All right, or 10 times x is equal to 6 times 5. It doesn't really matter the order that we do it. Just notice they're the same color because we're multiplying the parts on the same chord. All right, so 10 times x is just 10x. So 10x is equal to 30. Divide by 10, and we get x is equal to 3. That bugs me. There we go. All right, real simple stuff here. Should not take you too long. Let's look at number 2. So now we have the secant and a tangent. So we're going to do the tangent part first. So the outside, which is x, times the whole thing, which is x, right? Because it's tangent. The whole thing is on the outside. So x times x is equal to the outside, which is 4, times the whole thing, which is 4 plus 5. All right, so x times x is x squared, is going to be equal to, that's 9, so 4 times 9 is 36. How do we undo a square? That's right, do the square root. So square root of 36, which is going to be equal to 6. Whoa, what just happened there? Oh, they were two separate things. I can fix that. Okay, same formula. Now we have two secants, so there's two parts on the outside, so this one will take a while. But we'll do the outside of 6 times the whole thing, which is 6 plus x, is equal to the outside of 5 times 5 plus 16, which is the whole thing. All right, I'm going to have to distribute here. So I'm going to do 6 times 6 and then 6 times x. All right, so 6 times 6 is going to be 36 plus 6x is equal to 5 times 21, which is 105. And again, you can put that in the calculator if you're not sure. All right, so now I want to move the 36 to the other side. So this is kind of a longer problem. You're going to want to set these up. When I subtract 36 from 105, I guess I'll go ahead and show it in the calculator. So we have 105 minus 36, which is going to leave us with 69. Gavin. Okay, anyway, so we have 6x is equal to 69. So then I want to divide both sides by 6, which will give us x is equal to 11.5. So you're going to have a decimal there, so we definitely have to put that in the calculator because it doesn't go in evenly. If it was 66, then it would. But so we have 69 divided by 6, which is equal to 11.5. Yep. And that should be one of your answers. All right, last one I'm going to do with you. This one, the last problems, they're kind of like two problems kind of stacked together. So we have two variables we want to solve for, x and y. Just set them up as separate problems to solve for one variable at a time. So first, just look at these two chords intersecting here. So ignore the secants going on. So we have 3 times 13 is equal to x times 7. So I think I did that backwards, but 7 times x, okay, is equal to 3 times 13. That's 7x. And then 39 divided by 7, and we get x is equal to 5.6. Why is there an extra one? Ooh, that doesn't do anything. Okay, I forgot to delete that. Oh, I did lock it though. All right, so x is equal to 5.6. Now we want to solve for y. So we have two secants. Just kind of ignore the red chord here. So just look at the blue ones. Isn't the color coding nice? All right, so we're going to do the outside of 6 times the whole thing, which is 3 plus 13. So we got to add that together plus the 6 as well, right? So it's going to be 6 times 6 plus 16. Okay, so we had to add those two together. In fact, we actually added all those together if you want to do it that way. Is equal to the outside of 7 times the whole thing, which is 7 plus y. When we add that together, 7 plus y. All right, so add that together. That's going to give us 22. So we have... Let me double check that because I got a feeling that might be wrong. I probably did 21 instead. So 6 times 16, or sorry, 22. Let me delete one of those. All right, yeah, see, I was wrong. That should be 132. Close your eyes. You didn't see that. Okay, so that's 132. So I'll have to fix my answers as I go. But we're all human. We all make mistakes. We all have those days. All right, so... that's 132, and then 7 times 7 is 49, plus y, which will give us 7y when we distribute. So keep in mind on this one, we're distributing the 7 to the 7, which is 49, then 7 to the y, which is 7y. All right, I'm going to have to fix this one here, but when we subtract 49 from 132, so that minus 49, which is going to give us 83. So this is going to be wrong. All right, so 83 is equal to 7y. Let me fix it real quick. There we go. All right, then all we have to do is divide by 7. So 83 divided by 7. All right, and that leaves us with 7.9. Yes. Whoa. No, 11.9. All right. Would have been nice if it was the other one, but that's okay. All right, so that's it. That was 15 minutes altogether. That was really, really quick. So happy Friday, everybody. Short and easy day today. When we come back on Monday, it'll be a really easy lesson as well, just reviewing midpoint and distance. And then Tuesday and Wednesday, we're going to spend 2 days on the equation of a circle. You're going to wish you had a compass on that, but we'll see how it works out. We've actually done that assignment before, like the second week of school, when we did midpoint and distance with the foundations unit, with the class set of compasses, which was really fun. But I don't know. We'll see how it works out. Yeah, anyway, so I hope you guys have a good weekend, and I will see you again on Monday.